AC electrical power can be supplied by the left and right engine generators, the APU generator, or an external power source. DC electrical power is supplied from the transformer rectifiers and an aircraft battery. A separate battery is provided for APU starting and operation. The controls and indicators for the electrical system are located on the overhead panel. The primary sources of electrical power are the integrated drive generators, or IDGs. The IDGs incorporate the generator and associated constant speed drive into a single casing. For lesson purposes, the IDGs will be referred to as the engine generators. In flight, normal aircraft power is supplied by the engine generators, or, under certain conditions, the APU generator. During ground operations, the APU generator, or external power, can be used to supply power. Electrical distribution is divided into two systems: the left system and the right system. The bus tie system will automatically repower the affected system should a generator fail. The APU, or external power, can also power the systems utilizing the bus tie system. Now let's discuss AC power. The AC distribution system includes the AC buses, the utility buses, and the bus tie system. The main AC buses provide power to the utility buses and transformer rectifiers. The AC bus-off lights illuminate when the buses are unpowered and extinguish when powered. The utility buses supply power for the high load, low priority items such as galley power, and the recirculating fans. These buses are independently powered by the respective AC bus. The primary function of the bus tie system is to ensure that the main AC and DC buses are powered by any available source. The auto switch position allows the bus tie breakers to automatically open or close. This automatic feature performs three functions: prevents paralleling of the power sources, maintains power on the AC and DC buses, and isolates electrical system faults. In flight, the bus tie switches should not be actuated. Actuation may inhibit the automatic protective features. The bus tie isolation lights will illuminate when the switches are not in the auto positions. Also, with the switches in the auto position, the respective isolation light will illuminate should a fault occur on a bus. When the isolation light is illuminated, the bus tie breaker is locked open and cannot close until the fault is corrected. AC power can be supplied by either an external power source, the APU, or the engine generators. External power is controlled by the external power switch. The available light illuminates to indicate external power is plugged in and producing normal output. Pressing the external power switch to on connects external power to the electrical systems, utilizing the bus tie system. Pressing the switch again removes external power from the electrical systems. APU operation is controlled by the APU generator switch. Normally, this switch is left in the on position, which arms the generator breaker to automatically open or close. With the switch in the on position, the off light will illuminate only if the generator breaker trips open due to a fault. Selecting the off position illuminates the off light and removes the APU power from the electrical system. After engine start, the primary source of AC power is the engine generators. The engine generators are controlled by generator control units, or GCUs, which are activated by the respective control switches. Pressing the switch to the on position arms the respective generator for automatic operation. The switch off light will illuminate if the generator breaker is automatically tripped open or manually selected open. When an engine is started using external power with the generator switches in the on positions, the respective generator will automatically replace external power when normal output is achieved. External power continues to supply the opposite system. When the second engine is started, its generator will power the respective system, and the external power on light will extinguish. During an engine start with the APU supplying power and the generator control switches in the on positions, the respective generator will automatically replace APU power when normal output is achieved. The APU continues to power the opposite system. When the second engine is started, its generator will power the respective system. APU electrical power is still available if needed. However, the APU generator off light remains extinguished. The priority for automatically powering the main AC buses is the respective generator, the APU if operating, and finally the opposite engine generator. During normal operations, the engine generators power the respective systems. Should an engine generator fail, if available, the APU will power the affected system. Should APU power not be available, the opposite engine generator will power the affected system. External power has top priority when manually selected and will trip off any existing power source. Load shedding will cause either one or both of the utility buses to automatically trip off their electrical circuits. Load shedding can occur under the following circumstances. During engine start, while the APU is providing electrical power, during single generator operation in flight, or when a generator is overloaded. Load shedding can also occur anytime the throttles are advanced on the ground and a single power source is supplying power. Loads can be reset by returning the throttles to idle, then cycling the utility bus switches. When a generator overload occurs, the utility bus must be reset manually by cycling the affected switch to off, then on. Additional AC buses that are not depicted on the electrical panel include the Captain's Flight Instrument Transfer Bus, the First Officer's Flight Instrument Transfer Bus, the Standby AC Bus, the Ground Handling Bus, and the Ground Service Bus. The captain's flight instrument transfer bus is normally powered by the left main AC bus and supplies power for the captain's flight instruments. Should a failure of the left AC bus occur with the left bus tie switch in the auto position, the right AC bus will automatically power the captain's flight instrument transfer bus. The first officer's flight instrument transfer bus is normally powered by the right main AC bus and supplies power for the first officer's flight instruments. Should a failure of the right AC bus occur with the right bus tie switch in the auto position, the left AC bus will automatically power the first officer's flight instrument transfer bus. The AC standby bus is powered by the left main AC bus and automatically provides power to the essential flight instruments, navigation, communications, and lighting systems if the standby power selector is in the auto position. During ground operations, the ground handling bus is powered only by the APU generator or external power. This bus supplies power for cargo handling and fuel servicing. The ground handling bus is powered when the external power available light is illuminated or when the APU generator is operating. The ground service bus is powered by the right AC bus anytime the right electrical system is operating. Should the right AC bus not be powered, the ground service bus switch, located on the forward flight attendant's panel, will allow the ground handling bus power to supply the ground service bus. The ground service bus powers the two battery chargers, the left forward fuel boost pump, an equipment cooling fan, and some interior and exterior lights. Now let's try a few questions.